Hello, good morning, good afternoon, good evening. Thank you for joining us today for a very topical webinar session on how simulation can help port terminals prepare for remote operations. Just a quick audio check to make sure you can all hear and see me. Can I get a yes from someone?
Yes.
Yes, it's fine.
Yes.
Fantastic. Thank you very much. My name is Dave Clark. I'm CM Lab's Senior Product Marketing Manager, and I'm joined today by two special guest panelists I'll introduce in just one moment, but first, some housekeeping notes. This session should last 40 to 45 minutes or so, including a Q&A period at the end. I'd really like to leave time for that. For anyone who's interested in sticking around after the Q&A session, I also have some demos showcasing some of our most innovative simulators to date, but as I say, I will get into that after the main webinar session for anyone who would like to stick around. Also, for those of you who are new to this webinar platform, just a note that you can adjust your view using the blue slider that is in the bottom left corner of your screen if you are joining from a laptop or desktop computer. For mobile phones, you have a settings menu at the bottom of your interface. Once again, we will hold a Q&A session at the end of the webinar. Given the number of attendees here today, I think it would be best if you use the chat portion of the interface, but we will work that out together later on. Now, we're going to do things a little bit differently today. I've broken up today's theme into 4 separate topics. And for each topic, I'm going to ask our two guest panelists to provide their point of view from a technology perspective as well as an industry perspective. So the topics first, what are the triggers that would lead port terminals to consider a transition to automation? Second topic, what are the lessons learned from past automation efforts and what outcomes should you be expecting? Third, what considerations should you take into account? And finally, last topic of the day, how can simulation help you make a successful transition to automation? Once again, I will be turning to our guest panelists to provide their perspective. So without further ado, let me introduce them. Now, the way our webinar platform is configured, it's the speaker who should turn up on your main screen. So at this point, you should be seeing me as well as the slide deck I'm presenting. As Marc and Laila provide their perspective, they'll be coming up on screen as well, but let me introduce you to them on this slide. I'm pleased to present Laila El Moujtahid, who is Senior Product Manager for CM Labs, and of course, Marc Desmons, who is the owner and founder of the MarCrane Port Equipment Consultant Organization and the former Director of Equipment Engineering for TIL. Just to provide a background, a snapshot of Marc's background, he is, as I say, founder and owner of MarCrane, a consulting service specialized in port equipment asset management. He was highly involved in the design and procurement of the Hadron container terminal in Ashdod in Israel, and was responsible for the procurement of all equipment, including the remote operated STS and fully automated ASC, including all software. He also participated in the early design stage and choice of operation and equipment selected for the Valencia North Port Container Terminal. The MarCrane Port Equipment Consultant Organization is backed by 23 years of international experience in design, procurement, quality assurance and control, and maintenance and repair of port equipment. Services include assistance in performing smarter procurement, reflecting not only the price of the equipment, but the total cost during the lifetime of the equipment. Also, assistance in performing accurate ROI calculation for equipment, including operator assistance technologies such as DGPS, anti-sway, ship profiling, semi-automation, and full automation systems. MarCrane also provides analysis of automation implementation, type of equipment, level of automation, TOC, and ROI. To round off MarCrane's service offering, they provide complete analysis of the terminal M&R process and strategy, asset management software, and parts procurement strategy. They also provide assistance with a variety of processes, including technical job description, candidate evaluation, M&R organization chart analysis, as well as the complete process for the selection, implementation, and follow-up with CMMS systems. To introduce our technology speaker now, Laila El Moujtahid is Senior Product Manager for CM Labs. She's a dedicated professional focused over the last decade on innovation technologies, digital transformation, and product management. She graduated with a bachelor's degree in computer engineering from France and a master's degree in aerospace here in Canada. She specializes in creating complex and innovative digital products, including using cutting-edge technology to deliver sustainable value to customers with maximum impact on revenue and ROI. She's an advocate of an efficient, staged approach with a clear roadmap, involving a variety of stakeholders beyond internal and external silos and boundaries. In summary, she's focused on CM Lab's strategy of using innovative technology to produce actionable insights that can back the port industry's digital transformation. All right, now that I've introduced our speakers, I will present our first topic and then ask our speakers for their thoughts. First topic of the day, triggers for change. To contextualize the triggers, we do need to look at what's happened up to this point. As you can see from the chart on the top left, uptake of automation technology is not new, although certainly adoption was slow in the initial stages. That said, increase in adoption has been comparatively striking in recent years. One of the reasons for the relatively slow uptake initially is indicated by the chart on the right, which details some of the different areas that automation touches on. And you can see that adoption rates are variable according to the area of automation focus, with a convergence of adoption, across all port terminal areas expected sometime in the next decade and a half or so, hence the acceleration in adoption that we are seeing today. What's also variable is the decision, of course, to automate, which is dependent on different factors, including location, volume, labor costs, and so on. So let's look at those factors now. I've grouped triggers for change into 4 separate categories. First, the industry is upsizing. And when I say upsizing, I'm referring to larger vessels, increasing call size, bigger cranes, terminal expansion, and so on. No surprises here for any of us. Second category, the advent of disruptive technologies, including digital twins, Internet of Things, artificial intelligence, and the list goes on. The third category of triggers for change is the advent of sustainability initiatives, often driven by governmental and industry groups. And finally, of course, global events. Automation and adoption of semi-automation is increasing rapidly and certainly accelerated in the wake of the pandemic. Now, let's bring our speakers in. Marc and Laila, I would like to hear from both of you on these thoughts. First, Laila, can I ask you for your perspective on the disruptive technologies I talked about here?
So thank you a lot, David, for the introduction. Of course, investing on technology that improve both safety and efficiency is the best way to remain competitive these days. So as you say, David, because chips are getting bigger and goods are moving faster, ports require thousands of people, computer and industrial machines to work together each day. So making sure that the schedules are met on times and without any incidents is a true challenge. So the industry has already embraced many emerging technology, giving to the customer an end-to-end transparency on their operation journey. So let's focus on the digital twin. It's a computer program that uses real-world data to create simulation that can predict how a product or process will perform. This program can integrate Internet of Things, artificial intelligence, and software analytics to enhance the outcome. So digital twin ecosystem include both hardware to acquire and process the data, but also the software to represent and manipulate this data. So the approach is more powerful than existing model and existing simulation because it's leveraged the digital data stream to bridge the barrier between the physical entity and its representation. So now how to get this data? Introducing IoT technique into containers terminals enable port to collect, process, and store all data from a daily terminal operations. The idea, of course, is to rely on historical data, but also on fresh and raw real-time information. So don't forget that IoT is a giant mesh network that connects billions of devices, various processes, and people across the world. By collecting and sharing information about the way they are used, but also about the environment around them. Does that make sense, David?
It does, it does. I do find that the term Internet of Things or IoT is a little bit scary because when I hear IoT and millions of devices, what I understand is a vast amount of data. So how do you manage that data?
So it's a good question, and this is the big challenge today, because the traditional data management tools are no longer able to manage or to process the large size of information. So this is why we need to use a big data approach. So big data use a new methodology, new technique, new sophisticated software that incorporates data mining, storage, data sharing, and data visualization through a strong data framework. So this new technique rely on a strong AI and machine learning models, which can be applied for automations and apply a new sophisticated and advanced algorithm.
Thank you very much, Laila. That was fantastic. And just a reminder to our listeners, I will be turning periodically back to Laila for her perspective on the technology side of things. Now it really is my pleasure to bring Marc Desmons into the conversation. Marc, can I please ask you for your perspective on the triggers that are driving the industry's shift towards automation?
Yes, thank you, David. Automation should be an expected logistic investment, as it is in many other industries. But in the maritime industry, our industry, it has been much slower to jump on the train. Confidence in automation technology is at its highest in the recent years in terminal operators in general. We have full automation, which comprise of the stacking yard equipment and horizontal transport equipment, and we also have semi-automation, which is dealing with stacking yard equipment only. And the ship to shore is the equipment with the least automation development recent years, but prediction is that it will be the equipment with the greatest technology advancements in the next few years. It's the one equipment that is still far from reaching full automation. What triggers automation in terminal operators? There is a financial aspect, an economic aspect, and also environmental pressure from the various country legislation. The port infrastructure is forced to develop and improve to meet these demands required to service ever larger vessel. As we know, the size of the vessel has increased drastically over the last 20 years. We are now at 24,000 TEU vessel sailing on the oceans and calling the ports. The objective with automation is to minimize errors by reducing the human interaction in the process, to increase the efficiency, to reduce the cost of operating a terminal, to increase the safety by separating as much as possible man-human interface. And last but not least, reduction of the carbon footprint. As we know, most of the automated or semi-automated equipment are now fully electric rather than fossil fuel driven. So this is these are the main triggers for terminal operators to change to some level of automation on their terminals.
Got it. Thank you very much, Marc. Now let's move on to the second of our 4 topics. Topic number 2, lessons learned and expected outcomes. First, we do have to acknowledge the complexity of the transition towards remote operations. There are risks associated with automation, including management of labor relations, cybersecurity issues related to critical data, and maintenance and infrastructure considerations. I will ask Laila to speak some of the technology risks in just a moment, but let me first emphasize some of the other points on this slide. First, productivity increases are not necessarily guaranteed. The fact is that terminals adopting automated processes have reported declines in productivity, at least initially, and much of this can be attributed to training gaps. In fact, according to a recent McKinsey report, the top problem with automation is filling the specialized technical positions it requires, as even experienced engineers can take as long as 5 years to train. Before I get Marc's perspective on these lessons learned and expected outcomes, Laila, can I get your take, please, on the technology risks?
Exactly, David. So the implementation of new cutting-edge technologies, especially in port automation, leads to more and more cyber attacks scenarios. So, for example, today it's difficulty of protecting automated machines against cyber risk lie on their complexity. because terminals use industrial control system that translate sensorial data and command into mechanical actions. So the network links between mechanical equipments and sensors are exposed to the same threat as any IT network. For example, using your phone, etc. So security should be considered as a top priority to ensure compliance, but also business competitiveness. So port stakeholders should have a good understanding of the type of data to share, but also with who to share this information, understand the value of this information, of the technology, and the impact on their businesses. But still, the main obstacle in automation is linked to the quality of the data exchange, which is not precise for decision making, especially in automation. There is several reasons for this situation. First, the lack of structured and transparent data pool process that make it very difficult to apply quickly and to monitor or diagnose the performance of the equipments and operation. Also, the data come from various systems, application, devices, stakeholders, meaning OEMs, third parties, terminal, port, which make the environment very complex to manage. So now the question is how to standardize this information to allow the data to flow between different ports, OEM and third parties. So one of the approach is to have a common data infrastructure ecosystem shared between all ports, players and stakeholders, but also building a common port practices, meaning having a common connectivity norms. For example, are we using Wi-Fi? Are we using Bluetooth, etc.? Having the same process and procedure, using the same standard integration tools, standard business logics, and advanced simulation, such as digital twin, can help and accelerate this process.
Thank you very much, Laila. Thanks again for your technology insights. Now, Marc, I would like to turn to you if I can. What is your take on some of the issues that we have raised here?
Well, up until recently, equipment and system suppliers required to automate container terminals were coming from various suppliers, i.e. We had the equipment supplier for the ASCs or IMGs, the AGVs or the shuttle carrier. We had a TOS system supplier, terminal operating system, which came from another supplier. Then we also had equipment control system that came from various other suppliers such as Siemens, ABB, or others. So the complexity was that these were procured from 3 different suppliers that the terminal operator would try to need to make them work together and ensure a smooth transition between the various software systems and equipment and hardware. That was a very difficult process. And then when things were not working as planned, then it was, my experience was that it became a finger-pointing session. It's not the TOS supplier's system that is not working properly, it's the equipment system supplier, or it's the equipment supplier, and then in the end, the terminal operator would be stuck to pay additional costs to try to get things working properly. Only recently, the industry has started to offer a few suppliers have started to offer complete solution. Kalmar was the first one to do so with their TLS system as an ECS, equipment control system, the equipment itself, as Kalmar is known for, and the TOS from Navis, which came under the same umbrella. So it was possible to discuss a complete solution, but with only one supplier. In the recent years, suppliers such as MarCrane has also jumped into that complete system solution with their TOS from TBA AutoStore and Teams also for equipment control system. And when we did a few years back the procurement for the Ashdod container terminal at TIL, we were the first one to actually demand one contract from the equipment supplier, and it was their responsibility if they did not have in-house the software system such as TOS and ECS to subcontract to others in the industry, but the contract would be with the one supplier, and then they would subcontract. So it was done to eliminate the responsibility of the customer, the terminal operator, when it was time to integrate and test and eventually go live with the finger pointing session that I talked about. But that is very recent. Ashdod was the first one to go to that one step higher at the time. Unfortunately, due to the pandemic, the project has been delayed, that I hear from my former colleagues. But sometime this summer, the terminal should go live, and the test of this new way of procurement will be done. I'm confident that we made at the time the right decision. And more, the large equipment suppliers such as ZPMC and others are developing their own software systems such as the ECS and this is one of the challenge that the industry was facing, which is slowly now starting to adapt this new way of procurement. And so it's one customer dealing with one supplier mainly.
Thank you very much, Marc. Okay, here I have created a summary slide of some of the drivers, hurdles, and risks associated with the transition to automation. We are a little bit pushed for time, so I won't go into them all in detail, or in fact at all, but I will be sending all attendees today a copy of this full slide deck, as well as a link to the webinar recording, so you will have the summary slide for your reference. We'll move on now to the third of our 4 topics. Topic number 3, what are the considerations for a successful transition to automation? Well, data. In a word, data is key. Data helps port operators understand the root cause of delays and exceptions, and helps them clearly define problems and therefore solutions to those problems. In the absence of this approach to data, port terminals run the risk of unnecessary human error issues and lack of transparency in the event of incidents. Standardizing and analyzing data through a digital twin environment will be critical to future competition, and that means starting to audit, digitize, and normalize metrics and reporting. Now, both data quantity and quality are critical in this respect, equally so. In particular, the digitalization of training and the efficient use of training data are crucial. Laila, can I ask you for your take on this slide?
Thank you, David. Data is a crucial process, but it's also a complicated process. The issue today with applying analytics in port automation, it's related to multiple factors. So first, the large volume of data, it's extremely costly to generate, to manage, and process, and required huge software, hardware, and IT infrastructure, as Marc said before. The cost of having a good quality of data, it's expensive too. For example, data science spends almost 80% of their time just in cleaning and structuring the information. So because of these 2 points, developing and training those artificial intelligence and machine learning models require a very important financial investment. So this is why before deciding to jump or to adapt any data approach, very important to ask the following questions. What is exactly the problem that you're trying to solve? Framing the problem, it's the first step before jumping on these new technologies. How big is your data sets? Where will your data come from? As we said before, there is some security aspects. Knowing who will have access to your information is very crucial. And also, what type of data analytics that your businesses need. So one of the best approach to respond to these questions is to combine big data approach with current simulation. This is an entry for a digital twin journey applied for port automation. Why digital twin? Digital twin can help you to drastically reduce the cost of data acquisition, testing, and training your models. You can use this advanced simulation to select the right data analytics strategy before engaging any financial resources. You can also run this simulation again and again without any impact on our real-time resources. And finally, digital twin simulation will be the best approach to test and validate your strategy before any initial strategy investment, especially in automation.
Thank you, Laila. That's great. Now, I want to set up the next slide for Marc's commentary, but before I do, let me reiterate the final point on this slide, which is that the digitalization of training and the efficient use of training data are crucial. Crucial why? Well, here we're going to talk about the role of continuous training. One of the hurdles that terminals are likely to encounter on the road to automation revolves around providing workers with relevant technology skills, as well as the need to standardize processes from end to end. Okay, automation is not just pressing a button and everything happens, right? Humans will play a key role, even in the context of full automation, when things do not go as planned. They have to improvise, and in an even shorter time frame, they have to make decisions. That's why it's vital to implement continuous training, as during any exception scenarios, operators may find it necessary to perform operations manually, i.e. outside the system. Marc, can I get your take on these points?
Yes, as I stated earlier, the ship-to-shore is still an equipment that needs to be, at best, remotely operated. One remote operator per ship-to-shore. Now, when we go to the yard equipment, ASCs or RMG, or even RTG now, can be remotely operated with a ratio of 1 remote operator per 4 to 8 equipment, depending on the type of equipment and the level of exception handling. And then when we come to horizontal transport, the shuttle carriers or the AGVs are still considered like a pooling equipment. So when one equipment is having issues, then it can be taken out of the operation and replaced by a spare one. So simulation to operate ship-to-shore crane is still a bit different than the simulation to operate yard or horizontal transport. And what I mean by that is that the training simulator for ship-to-shore needs to replicate operation of the ship-to-shore remotely, but also operation of the ship-to-shore in a cabin on the crane as a backup. So the simulator has to have a very, very similar, if not identical environment than the crane or the remote operating station. So I was one that wanted to have the remote operating station for ship-to-shore, a replica of the cabin on the ship-to-shore, roughly. And instead of windows, then we had monitors. And then the simulator has to be an identical replica of these, where when it comes to yard equipment or horizontal transport, then a simulator needs to replicate the environment, i.e. the view on the terminal, the view of the operator in the terminal, and to some level, the equipment itself. The training via simulator is for inexperienced operators, mainly at first. 90%, I mean, my experience with training on simulators is that it is used to screen who has the capability to become an equipment operator, either on the equipment itself, like in man terminal, or remotely. The results are very similar, where when we do an initial session with new candidates, only about 30% of those pass with success. That means that 70% of the people that went through the basic training on simulator do not have the ability to become efficient operators. But from those who pass this initial training, the 30%, then the success rate to become an efficient operator is 99%. So, and this is where simulation comes very handy, and where the return on investment is we do not spend hours and days and months to train potential operators to realize in the end that they cannot become potential productive operators. We can do a very early screening, and then those that are going through the screening become successful operators. So, and then from there, simulators is used to reply as much as possible. Simulators is used for when the instructor realizes that there are certain weakness with some of the operators. He can then design specific training on the simulator to address these weaknesses with the operators and make them become more productive operators. So there is an initial training role for simulators, but there's also a continuous role for training to then address weakness or address trends that some of the operators are bad trends that some of the operators may adopt, and to correct that and to keep level of productivity and even increase the level of productivity.
Thank you very much, Marc. That is great. Now I will move on now to the final topic of the day. Final topic: how can simulation help you make the transition to automation? Here we are, a continuum of training needs. Let me break this down so that you can understand it. Here we go. Wherever you are on your journey to automation, that's indicated along the top row with manual operations on the left, remote operations on the right, and transitional or semi-automation in the middle of that top row. Each of these areas has a corresponding recommended training focus and corresponding technology in line with the continuous training that Marc was just referring to. First, for manual operations, the recommended focus is on using simulation technology to efficiently train operators up to your safety and productivity standards. In the intro video that we used to kick off this webinar session, you might have seen, you will have seen some of the simulators that we provide to port terminals internationally for this purpose, including simulators for STS, MHC, ship pedestal cranes, as well as straddle carriers, RTGs, ECH, forklift, and more. Next, as you move along the continuum on the journey toward full automation, you will need to identify the top operators who can adapt to and help steer the transition. That's where CM Lab's Instructor operating station, you see at the bottom, comes into play, and I'll show you what that looks like more tangibly in just a moment. The point is that CM Lab's training simulators connect to the Instructor operating station to track, record, and report on objective metrics that you can customize to reflect your operating priorities. Not only does this allow you to set objective benchmarks on an equal playing field for all operators, but it also lets you establish a performance database reflecting standardized assessment protocols. Ultimately, this Instructor operating station makes it easier to objectively identify your top operators and undertake any upskilling initiatives accordingly. This is critical because the straightest path to increased efficiency consists of bringing total workforce productivity up to baseline levels. Why? Because this sidesteps the hero syndrome that characterizes many initial pushes towards automation. And what I mean by hero syndrome is where your success relies on the talent and frankly the will of truly exceptional staff. This approach can be difficult, if not impossible, to replicate consistently, and that's why it's essential for port terminals to leverage the data provided by tools such as the Instructor operating station. This really allows them to perform an objective gap analysis of workforce skills. Again, without such tools, port terminals often experience the disappointing automation results that we alluded to earlier. On the remote operations side of things, CM Labs provides training simulators to help operators make the adjustment from manual to remotely operated equipment. The transition is not straightforward simply because with remote operations, they are deprived of the senses of motion and the tactile experience of operating a crane or other machine manually. So the remote operating Station Simulator allows operators to gain weeks and months of experience, potentially even before commissioning of the remote equipment. So that's what this slide is about. Just to reiterate and tie this slide back to what we were discussing before, beyond its pure training value, using simulation-driven training data helps establish baselines, acquire objective performance data, consolidate that data across multiple users and terminals as required, and leverage analytics tools to iterate and improve on processes. Now, here are some visuals representing the Instructor operating station I was referring to on the last slide. Physically, what it looks like is a computer, monitors, keyboard, mouse, but what's under the hood is software that captures, tracks, and reports on operator performance data, both real-time data as well as persistent data. There is built-in flexibility for customizing not only the way key performance indicators are reported, but also for customizing the training exercises themselves. Once again, this Instructor operating station can work with both the manual equipment simulators as well as the remote operating station simulator. Speaking of which, this is what it looks like, a simulation-based training solution for remote STS or RMG operators. It can be connected to real PLC hardware or to emulated crane control systems, providing both basic and advanced remote functionality. Now, once again, following this presentation and the Q&A session, I will be playing brief demonstration videos for anyone who is interested. Now, before I conclude and move on to the Q&A session, I just want to reiterate some of the key points I would like everyone here to take away from the presentation, and I will ask Marc once again for his thoughts on this before we wrap up. First point, it is vital to ensure operator readiness as well as redundancy capabilities. This was amply demonstrated by the effects of the pandemic. Continuous training is the name of the game. Second, use simulation to generate objective performance data and make plans to consolidate this data across multiple users and terminals. Third, the data from simulation-based training to establish baselines, apply analytics, improve processes. That data is key. And finally, as Marc was alluding to earlier, establish commercial partnerships early in the process. Now, Marc, can I ask you to weigh in on these key takeaways and the transition to automation?
Yes, a few important or word of advice I could give is, as you stated, establish commercial partnership early in the process. Adopt the one solution provider rather than multiple provider, and try to connect the dots as you go along. It wasn't done in the case of Ashdod, but I would now, with the experience project I worked on, is include simulators as part of this one solution. As you say, the simulator needs to be, as I said, it needs to be as close as possible to the realistic remote operating stations or equipment, because there are still some equipment, even in full automation, like the ship-to-shore, that are not fully automated. The reduction in labor is not as great as people sometimes think it would be. There is a reduction in labor, but not that great. And the biggest challenge is in the old days where we were having manned equipment, the challenge was to find and train some equipment operator. And then we needed some basic mechanic and electric and control system technical people to maintain, repair, and maintain this equipment. Now the biggest challenge has become to find the technical people to maintain and repair these complex equipment with artificial intelligence, and not so much the people to operate the equipment, because to learn to operate remotely in equipment, we seem to be able to find more easily people that qualify via basic training simulation to remotely operate equipment than the good old ways on the equipment. And the last word of advice for me would be the challenges with the union labor is probably the biggest challenge ahead of us. Not so much the case in Asia or Africa or places like that, but when automation is coming to Europe and North America, this is a big challenge. There are experiences in the West Coast of the US, California mainly, where the reduction of personnel has been zero because of labor relation and so this is something that needs to be taken into account. The relation, in the return on investment, the reduction of labor is nil or very low if we only base it on the cost saving of labor. So this is a few words of advice that I could give to people looking into automation.
Thank you so much. Thank you so much, Marc. That was fantastic. Moving on now. So before we move to the question and answer session of this webinar, I just want to give you a few words about CM Lab simulations and let you know who we are. Our vision is to be the leader in digital transformation from machine design all the way through to operator training. Our mission is to simulate the world to make operations safe and efficient by connecting people, processes, and equipment design. We are headquartered here in Montreal, Canada. We've got over 1,000 simulators installed worldwide, all built on Vortex Studio, which is our proprietary real-time simulation platform. Our partner and support network is global, and we are the world's leading provider of simulation-based solutions. Our focus on innovation stems from our background in research. Research is led by in-house PhD physicists, engineers, mathematicians, and over 300 academic papers have been published by CM Labs. With 125 employees and 85 engineers in R&D, we are also proud to partner with leading educational institutions, including award-winning collaboration with McGill University. With that, I will pause on this slide to let you all take notes. If needed, you can contact us at any time at info@cm-labs.com or visit our website at cm-labs.com. At the bottom of this slide, you will find the contact information for our two guest speakers, Laila El Moujtahid and Marc Desmons. A sincere thank you to both of you, Marc and Laila, for your thoughts today. And with that, we will move on to the Q&A session. I think that with the number of attendees here today, it might be best for you all to post questions in the chat box of your interface. If that doesn't work, we can try unmuting and see how that goes. So with that, I will stop sharing my screen just so I can see the interface. I can see we have a number of questions on the chat. I'm going to scroll back to the beginning if I can. Okay, I see we have some discussion in the chat. Do we have any questions for our guest panelists today? Feel free to unmute as required.
I have a question.
Yes.
Yeah, I noticed that you mentioned about 5 years necessary training. I mean, how do you look at the future? Obviously, the technology is going to continue to get better. Maybe it's not going to take 5 years because to me that sounds, you know, with the way I'm looking at it, there's going to be a tightness in the job market as we move forward for experienced personnel. So how do you handle that?
Thank you very much, Michael. Marc, can I pitch that question to you?
Yes, well, 5 years is roughly the time it takes nowadays. Now, we all know that 5 years in IT and software is a very long time. So by the time you have your people trained on the system that you have implemented, it's time to upgrade that version or upgrade the complete system. So it's a continuous learning curve. You train your people to use the system, you start to become efficient, you benefit from this efficiency for a few years, and then it's time to modernize and upgrade your artificial intelligence. And then it's not a complete retraining, but it's a continuous learning curve, both for the people that will operate this this automated system, but also for the industry to keep bringing new products that will be more and more efficient. And so to me, it's yes, it's going to be challenging. The biggest challenge, like I said earlier, is to find the labor that can meet the demand of the terminals. Now, in places like Asia, Europe, and North America, it's easier to find. But then we have labor relation challenges, where we cannot just simply eliminate some manned operation. And in places like the Middle East or South America or Africa, where it is a bit easier to implement such system, then the challenge is finding the people to operate and maintain these systems. This is why the remote assistance of the various suppliers is become a must nowadays. The days of needing a technician and having him jumping in a plane and being there 24 to 48 hours later are over. We've experienced in the last year, because we were forced to do everything remotely, we've experienced that remote support from suppliers can be very efficient. And so this is something that we need to consider with the difficulty to find technical people to operate and maintain these systems. Then the remote support of the suppliers has become ever more important.
Thanks very much. I have a question. So you alluded earlier to the expectations with respect to ROI and labor and so on. I know that you've spoken in the past to some of the cost savings that you can achieve by using simulation in the training stage, or rather the assessment stage of new operators. I wonder if you could speak to that, Marc.
Yes, the cost saving comes a lot from in the old days we were training operators on equipment directly. So you needed to take one ship to shore or an RTG or two to train the people. That has a cost. You're putting hours on an equipment without any productivity, and you're also taking that equipment out of operation. And to train people, it's not only taking the equipment 1 hour here and there to train people. You need at least, our experience is you need 4-hour session to have a really beneficial training session. So training via simulation is reducing that cost of using real equipment that is that should be in operation rather than training people. So there is a cost saving there. And the other cost saving is, like I said, is that we can screen very well with an initial 4-hour session. That's our experience. That's what we've implemented when I was working at TIL in Klaipeda, in Lomé, Togo, in Turkey, in many terminals. TIL had three terminals that were used also as training center for operators. And the experience is that by doing this 4-hour session, we only have a 30% success rate. But out of that 30% of people that go through it, 99% of them successfully complete the full operator training session. And this is across all types of equipment. So the cost saving really comes from, we are not training people that we realize down the road don't have the ability to become productive operator. We can screen them very early on at a very low cost and without having to use any real equipment. And this is really the return on investment from training via simulators. And the results, whether it is for manned equipment or automated equipment, so operation on exception handling and that type of stuff, or emergency situation, is the same. Whether we are training operators for manned equipment or operators for remote operated equipment, the result is the same, that 30% and 99%. And this is really where the return on the investment comes from, and the cost of a really good simulator is very quickly paid back.
Thank you very much, Marc. We have another question in the comments.
Can I ask a question?
Yes, one moment. We've got a couple of questions coming in. The first question I'm going to pitch to Laila. Somebody has a question about digital twins and how to create them. Laila, I wonder if you could expand a little bit on that concept for us.
Yes, so thank you for the questions. We have our Vortex work where we are starting introducing IoT inside our existing simulation tools. So we are working also with some suppliers to, I would say, translate this data from CAD files. So, because I'm looking to the question in the chat, we are in the early stage of developing our digital twin. So the concept is introducing some AI advanced algorithm inside our Vortex software. We already did some proof of concept in the past, and because now the industry is going in this direction, we are working internally on improving our digital twin solutions. So, yes. I don't know if I respond to the questions.
Thank you very much, Laila. I believe somebody else had a question.
Yes, I have two questions. So, good morning. My name is Noel Brown. I'm joining from the Caribbean Maritime University in Kingston, Jamaica. The first question is going back to what was said earlier about training engineers. It would take maybe about 5 years to get them trained and things like that. During that 5 years, what about, is there risk of damage to the technology, and that might be come with a cost? That's the first question. The next question is if it has been, well, a lot of people, once they think about automation, what they think about next is the reduction of staff. So they figure that they will lose their job. However, in this webinar, I heard that there would not be a substantial increase in, job loss, or people would maintain their job and everything. Now, one other thing is that how do we convince people of the fact that they would not lose their job? And the third and final question is that if the second question is correct, why would I invest in automation if I'm gonna keep my staff? Because investing in automation would come with a hefty cost, and then I would still maintain all my staff. What would be the win for me then? Thank you.
Thank you very much. No, yep, go ahead, Marc.
Hey, David. The reduction of staff we've seen in certain areas is between 8 and 15%. Mainly what is happening is we are reducing the number of operators, equipment operators, but then we're increasing the number of technical staff because we need more people to maintain. And then there is a reduction, like I said, between 8 and 15%, depending of the areas where we are. Now the return, so this is why I said the reduction of staff is not the main driver. The return on investment comes from, although the peak productivity of an automated or semi-automated terminal will never reach the peak productivity of a manned terminal. So a human being can have peak production over a period of 1 hour, much higher than an automated system. But the average productivity of an automated system is very constant and steady. So at the end of the day, the difference between the average productivity of a manned terminal and of an automated terminal is not that great. It is still lower, but it's not that great. But one of the advantages is that the cost of operating terminal is the same whether it's day, evening, or night, whether it's Saturday or Sunday, whether it's a holiday or not. The cost is the same to operate that terminal. Here in North America, when people are working evening shifts or night shifts, they are making 150% or 200% salary. So operating outside of regular working hours becomes very expensive, where with an automated terminal, the staff required in evenings and nights are only staff there for emergencies. If there's a problem with the system, if there's a problem with an equipment, the maintenance staff itself is working regular working hours. So the reduction in labor cost is still there, although the staff reduction is not that great. So the main payback is to have a steady productivity, to have a productivity that has the same cost 24/7, 365 days a year, and also the reduction of collision, accidents, safety with the personnel. That is a huge save in cost, because the amount of accident on an automated terminal is by a very large number much lower than a manned terminal.
Thank you very much, Marc. So somebody in the chat section is asking if it's possible to quantify what we've just explained. I assume that's in reference to the number of incidents. I don't know if you would have those stats at hand, Marc. It's certainly something that we can dig into and provide after the webinar. Unseld, are you looking for numbers on a specific dimension of operations? At this point, I'll just say that we're happy to follow up with anyone after the webinar. Certainly happy to pursue all conversations via offline channels. I do see some requests for the video. So at this point, I'll just thank you so much for all of your questions. As I say, if other questions occur to you following the webinar, please do send them our way. With that, I will conclude this presentation. And once again, thank you so much to Marc and Laila for your insights. I look forward to working with you both again. To our audience, a very special thank you for attending. I hope we are able to cross paths in the near future. Once again, I will send everyone here a copy of the webinar recording as well as a copy of the slide deck. I will conclude this webinar. Anyone who would like to stick around for a brief video introduction to our most recent remote operations training simulators, please do stay tuned. I will launch that video in just about 60 seconds, 90 seconds after a brief outro video. So please do stay tuned if you are so inclined. Thank you, everyone, once again.